Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. A compound is achiral if it is superimposable on its mirror image. This occurs when the molecule has an internal plane of symmetry, mesocompound, a center of inversion, or an alternating axis of symmetry. Step 1. Analyze option A. The bicyclic anhydride has two methyl-bearing bridgehead carbons, both shown with wedge bonds, both Me groups pointing the same direction. The two bridgehead stereocenters are set, and the molecule lacks an internal plane of symmetry. This compound is chiral. Step 2. Analyze option B. The structure appears to be a tricyclic cage hydrocarbon, resembling a twistane or similar cage. Without substituents and depending on the exact connectivity, one must check for symmetry. This particular cage structure, as drawn, resembling a twisted admantane or similar polyhedral hydrocarbon, thus poses a C2 axis but may lack a mirror plane, making it chiral. It could be twistane, which is chiral. So option B is chiral. Step 3. Analyze option C. The admantane derivative has Br at one bridgehead and two Cl substituents placed symmetrically on two equivalent carbons of the admantane cage. Each of the two Cl-bearing carbons also bears an H. The arrangement places the two CHCl units symmetrically with respect to a mirror plane that passes through the Br-bearing bridgehead and bisects the molecule. Because the two CHCl groups are mirror images of each other within the same molecule, one has H wedge Cl' on the left, the other has H wedge Cl' on the right in a symmetric fashion. The molecule is a mesocompound. It has an internal plane of symmetry despite having stereocenters. Therefore, compound C is achiral. Step 4. Why not D? Since A and B are chiral, not all three are achiral, so D is incorrect. Conclusion: only compound C is achiral due to an internal plane of symmetry, mesoform. Therefore, the correct answer is C. Therefore, the correct answer is option C.